factor special products. That includes perfect cubes, perfect squares. Before we jump into those problems, let's just quickly review what are the perfect squares and what are the perfect cubes. We talked in the last section about perfect squares, so let's just refresh your memory. Perfect squares would include 1, 4, 9, 16, 25, 36, 49, 81, 100, 121, and 144. That's probably as high as you would see on a test. However, you might have some higher perfect squares to appear in your homework. Right while I've got it on my mind, when you're doing the homework in my math lab, it's fine if you want to click similar exercise and get a new problem with different numbers. I don't have a problem with that. So you might decide to do that. Sometimes these numbers, when you're doing perfect squares and perfect cubes, sometimes those numbers can get really, really big. So if you need to use a similar exercise problem in your homework, that's okay. But at any rate, you need to be able to recognize all of these numbers as perfect squares whenever you see them in a factoring problem. The perfect cubes that you need to be able to recognize would be the following. So we know that 1 to the third power is 1, 2 to the third power is 8. The next one would be 27, 64, 125, 216, 6 to the third. All right. 343, I think, is 7 to the third, and 1,000 is 10 to the third. I will not ask you any number that is not included on this list. I will not expect you to immediately recognize any number that is not on this list as a perfect cube. Again, it may come up in the homework, but if it does, you can, just kind of try to do it, or you can do a similar exercise if you need to. So these are the perfect squares, the perfect cubes that we need to be able to recognize as we begin to work with factoring methods for special products. So in your notes, there is discussion about the difference of squares, sum of squares, the perfect square trinomials. Read through that. Make sure that you know that if you see a sum of two perfect squares, for example, if you see x squared plus 4, this is a prime polynomial or a prime binomial. This does not factor. You could play with this thing and try to get it to factor as much as you want to, and I might let you do that in class as practice. But if you play with this thing, try to put numbers in that if you were to FOIL it back out, would give you this. As you play with this, you'll find that you can't do it. So the sum of squares is prime. The difference of squares, so what if we just change this to a subtraction instead of to an addition? So instead of x squared plus 4, what if you're doing x squared minus 4? Okay, you need to be able to recognize x squared is a perfect square, 4 is a perfect square. So we're going to apply the difference of squares formula. A squared minus b squared equals a plus b times a minus b. The a and the b are whatever values that you need to square in order to give you these two terms. So in order to get x squared in your first term, your a would be x. B would be, what would you square to give you a 4? It would be 2. You don't have to worry about a negative here. So putting these values into the difference of squares formula is going to give you x plus 2 times x minus 2. And once you apply your formula, unless you forgot to remove a GCF at the very beginning, once you apply that formula, you're done. Okay. All right, in example 5, we are asked to factor using the special products. In part A, we've got 4x squared minus 1. When you approach this problem, again, you need to make sure that you can identify those perfect squares. You need to immediately recognize that this is a perfect square, 4x squared, and 1 is a perfect square. If you can do that, then you can factor it. All you need is the difference of squares formula, which we talked about a moment ago. You need to determine what your A and your B are. So A in your formula is whatever you're squaring to give you your first term. So A is 2x. B is whatever value you need to square to give you the 1. So that would be 1. Apply your formula, A plus B times A minus B, and you have 2x plus 1 times 2x minus 1. All right. And again, unless you forgot to remove a GCF from the very beginning, once you apply your formula, you're done. So for part B, you may recognize this as a perfect square trinomial, and you can use the formula that's given in the notes. However, it's not. You can also factor it as you would any trinomial. But let's do the grouping method like we discussed before. In order to do the grouping method, you're going to want to first of all, your first term, the coefficient is a 1. So if you're thinking of A times C method, it's 1 times 9. So you need factors of 9 that you can add or subtract to give you a negative 6. So you could do 1 times 9 or 3 times 3. Okay, we're going to need to do the 3 times 3. All right, and then we need to add these together to give us a negative 6. So they need to both be negative. So we've got x squared minus 3x minus 3x plus 9. Keep in mind that because this is a perfect square trinomial, when we get finished, the two binomials need to be identical at the very end of the problem. So let's see what happens. Looking at the first two terms, I can factor out a common factor of x. That leaves x minus 3. And then looking at the last two, I've got a common factor of negative 3. So we'll factor out negative 3. And again, if this part confuses you, you can think of this. All you're doing is you're saying plus negative 3, and then what is left if you factor a negative 3 out? It's going to become positive x minus 9. I'm sorry, minus 3. Okay. Now we have a common factor of x minus 3. So this x minus 3 inside parentheses we're going to pull to the front as our common factor. And we're also left with another x minus 3. All right, and that's how we know that that's what we mean by perfect square trinomial. We should be getting the same factor multiplied by itself. That's what makes the perfect square. So you can write this as quantity x minus 3, or excuse me, you can write this as x minus 3 quantity squared for your answer. Okay, so in example 6, we're asked to, it just says factor the polynomial. They don't really tell us what method to use here. In part A, notice that you've got an x cubed and 27. Hopefully you recognize from that list that I gave you earlier as 27 is a perfect cube. 27 is 3 times 3 times 3. So if you recognize these as perfect cubes, then that is your indication that you need to use the difference of cubes formula. Why the difference of cubes? Because they're being subtracted. So A, for your formula, is going to, what do you cube to give you your first term? A is x. What do you cube to give you your last term? B needs to be 3. All right, and my formula, again, it's in your notes. Difference of cubes formula states that a cubed minus b cubed equals a minus b, parentheses, times parentheses a squared plus ab plus b squared. So using the formula, we're going to have x minus 3 in parentheses times x squared plus a times b is 3x plus b squared, which is 9. Okay. Again, the nice thing about these formulas is that unless you have forgotten to remove a GCF at the very beginning of the problem, once you applied your formula, you are finished. You do not have to go another step. So this is our answer. Okay, let's look at part B. We're going to factor 8w to the 6th plus 125z to the 3rd. How in the world are we going to go about factoring this thing? Well, hopefully you recognize your 8 and your 125 as perfect cubes from the list that I gave you earlier. Also, these exponents, since they're divisible by 3, they're also perfect cubes. So these are being added, so we have a sum of cubes. Always make sure that you get any GCF. Is there anything that we could take out of these two terms? There is no common factor between either the variables or the coefficients. So we're just going to jump into the formula. We're doing the sum of cubes formula. It's a cubed plus b cubed equals a plus b in parentheses times parentheses a squared minus ab plus b squared. So we're going to do our a. What does our a need to be so that if we cube it, we get this? A needs to be 2w to the third. No, I'm sorry, 2w to the second. 2 to the third is 8. And then if I multiply w squared by itself 3 times, that gives me w to the 6th. B, what do I cube to give me 125? I need a 5 for my coefficient, and I need a z. And now I'm ready to substitute into my formula. So if I do a plus b, that's 2w squared plus 5z. Okay, and then I've got the trinomial. When I do this, I'm going to use some square brackets because I'll have parentheses inside parentheses. So I'm going to do a squared, so that's going to be 2w squared, and then I have to square that. The formula tells me to subtract a times b, so I'm going to do 2w squared times 5z. Plus, and then b squared, which is I'm going to square 5z. Be careful that you square both the coefficient and the variable in these problems. A lot of times students forget that they have to square both the 5 and the z. So let's see if we can simplify this. There's not anything that I need to do with the very front binomial. The trinomial will become 4w to the 4th minus, that'll be 10w squared z plus, that's going to be 25z squared. All right, and again, the nice thing about these formulas, like I said before, is as long as you didn't forget to remove a GCF, once you use your formula, you are done. So it looks like a lot of stuff in here, but we're finished. That's all we have to do. We applied the formula, and we can move on to the next topic. Okay, so a very important skill that you need in this course, or really any math course beyond this, is being able to factor completely. In order to factor completely, that means that you have factored everything that can possibly be factored is factored. As an example, let's look at example 7, part A. We have negative 3x to the third plus 27x. When you're asked to factor completely, the first thing that you need to do is determine if you have a GCF. Is there anything that can come out of all your terms together? If there is, you need to pull the GCF out to the front first. The next thing you're going to look at is the number of terms. The number of terms will help you determine which method that you need to use. This one definitely has a GCF. We notice a common factor on the coefficients of 3, and then each of them have a common variable of x. Also, you'll notice that the first term is negative, and generally we prefer to avoid starting out with a negative. So anytime our first term is negative, we'll go ahead and factor whatever GCF that we're going to factor out, we'll factor the negative of that out. So let's factor out for our GCF negative 3x. If I factor negative 3x out of my first term, I'm left with x squared. And factoring negative 3x out of 27x is going to leave me with negative 9. Can I go any further? Well, x squared minus 9, that's something that we need to be able to recognize as a difference of squares. Again, x squared is a perfect square, 9 is a perfect square. They're being subtracted, so because that's a difference of squares, yes, it can go a step beyond this. Your difference of squares formula, if you recall, is a plus b times a minus b. So in this piece, a, what do I have to square to give me x squared? Well, a is going to be x, and b, since I square 3 and get 9, b is 3. So bring your GCF down. Use your formula. A plus b is x plus 3 times a minus b gives me x minus 3. Okay, now I look at what I have left. Could I go any further than this? The answer is no. That's as far as we can take it. So our answer is negative 3x times x plus 3 times x minus 3. In example 7, part B, we're asked to factor 2w to the 4th minus 32. Again, we need to look for a greatest common factor first. Is there anything that comes out of all of my terms? I can see that 2 comes out of both of them. So factor your 2 out. I'm left with w to the 4th minus 16. Can I go any further? Well, w to the 4th minus 16 can be factored further. Hopefully you can. Do you see why? What is special about what I have here? Does 16 look familiar? That's in our perfect squares list. W to the 4th is a perfect square because your exponent is divisible by 2. So we have a difference of squares. Our A is w squared. Our B is 16. Excuse me, our B is 4. So we can bring the 2 down. That leaves w squared plus 4. And this is just using the formula, a plus b, and then a minus b is w squared minus 4. So I got this piece using my difference of squares formula. Look at what's left. W squared plus 4, can I do any more to that? No, I cannot, because yes, these are perfect squares, but these are being added. And if you recall, the sum of squares is prime. That's the one that I told you to play with on your own and see if you could figure out how to get it to factor. By manipulating all those possibilities, you'll see why it does not factor. So the sum of squares is prime. We don't need to do anything to that. W squared minus 4, that's a difference of squares, and that can be factored. This time our A will be W. Our B will be 2, since 2 squared gives me 4. So we'll bring down the GCF and the other factor that we have, and then we're left with A plus B. This time is W plus 2 times A minus B is W minus 2. And because there is nothing more that can be done here or here, we've got a sum of squares, which is prime here. That's as far as we can take it. So this is completely factored. Okay, and that brings us to the very last problem for section B4. So what do we do this time? We're going to factor. We have to factor completely. We have 4 terms. Well, 4 terms is telling me I need to think about the grouping method. Before I jump into this, though, is there a common factor that I can take out of everything? You always need to look for your GCF. If you look at all 4 terms, you will see that the GCF of all of this is 1. So there's no GCF that needs to be pulled out first. So with this being 4 terms, let's do the grouping method. Look at the first 2 terms. These share a common factor of a squared. That leaves me with a plus 1. Over here, this is a subtraction in between, so we're going to whatever comes out, we're going to factor out a negative. So we're going to say minus 4 parentheses, and we're going to factor out negative 4. That leaves a plus 1. So our factors a plus 1 and a plus 1 do match like we need them to. We could pull out the a plus 1. That leaves us with a squared minus 4. Can we go any further? A plus 1, no. A squared minus 4, hopefully now you're seeing that, yes, we can go further with that. That's a difference of squares. That will factor as a plus 2 times a minus 2. just using the difference of squares formula. So I've got a plus 1 times a plus 2 times a minus 2. And that is as far as we can take this one. All right. So you've seen all the examples that you need from this section. You are ready to do the quiz. When you've got 4 questions in the quiz, and you should be able to find like an identical twin, except with just different numbers, from among the examples that we've done together. So good luck with the quiz, and I will see you in class.